So chapter 3, section 1 is called Identifying Pairs of lines and angles. Okay, again, a lot of definitions. So we start with parallel versus skew. Parallel lines are coplanar lines that do not intersect. So they have to lie in the same plane, and they can never intersect. Skew lines are non-coplanar lines that are neither parallel nor intersecting. So these do not lie in the same plane, which makes them not parallel, but they also don't intersect. Okay, so this is where it gets a little tricky. Most of you know what parallel lines are, right? Like, so if I look on the floor, you've got parallel lines running this way, right? They're never going to intersect each other. You've got parallel lines running this way, right? If I go like this and this, that's going to be intersecting lines. Those aren't parallel. Those are all coplanar, right? Same thing if you look up in the ceiling tiles, anything that's running like north-south and then east-west, those are all parallel lines, right? Skew lines can't lie in the same plane, and they can't intersect. So if I look at like the top corner and I go across the wall here, and I look at the bottom corner and I go across the wall there, are those parallel or are those skew? Can they make the same plane? Can they be on the same plane? Yeah. If they're heading in the same direction, they are parallel, whether there's a plane visibly there or not. So a line in the ceiling like this and a line in the floor like this, they're parallel because you can make a plane, okay? Even if the plane's not there, you can make it. Does that make sense? Mm-hmm. Yeah? So if you picture this room to be a box, the top corner that's running that way and the bottom corner that's running that way are also parallel because I can make a plane that runs diagonally through this room. Does that make sense? So for it to be skew, they have to run in opposite directions. They have to be something like a line in the floor that's going this way and a line in the ceiling going this way. Those are skew. You cannot draw a box. There's no box there, you can't draw a box. Does that make sense? Okay, so if I actually had a box, like if you could... If I had a box, right? Let's say that this. Okay, these are parallel, okay? These are parallel because I can actually physically connect these to make a box that way. Do we see that? Yeah. Yep. Skew would be like something here and then something, not that one, something here. They don't ever touch, right? They're going in different directions, but they're not in the same plane. Does that make sense? No. So the yellow, if you look at the yellow, right? Yeah. Picture that to be like the front corner of a box. Like, where's my tissue box? I have a prop. Right. Front corner of the box. And then, so something running side to side and something running up and down. Those are going to be skew because they're never going to touch, right? But they can't make a plane. So, like this.
If you extend it, won't it intersect?
Parallel planes are planes that don't intersect, okay? So this is the top and the bottom of a box, the front and the back of a box, the left and right sides of a box. Planes that do not intersect. So if I said plane AGFD, which is this left side here, what plane is parallel to that? B. Good. This plane here, okay? If I did the front side, it'd be the front, which is GHFE, and then the back side, which would be ABCD, okay? If you did top and bottom, front and back, left and right, all those things are going to be parallel planes, okay? Make sense? Yes? Okay. Postulates. So there's 2 postulates we need to know, and you can know them by name. Save yourself lots of writing. And know them by name. The first one's called the parallel postulate. If there's a line and a point not on the line, then there's exactly one line through that point that's parallel to the given line. I'll draw you a picture in a minute. But I'll let you write it out first. If there's a line and a point not on the line, then there is exactly one line through the point parallel to the given line. And perpendicular. If there's a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. Okay, so if I start with a line, again, I got a line. And the first one says the parallel postulate. So it says if there's a line and a point not on the line, so I've got a point not on the line, then there's exactly one line through the point that's parallel to the given line. So again, I could ask 10 of you to come up and try to draw a line that passes through that point that's parallel to the bottom one. And no matter what you draw, it's always the same line. Keep in mind, that's crooked, but keep in mind that that doesn't mean the length of what you drew is going to be the same. Somebody could come up and draw a little line like this. Somebody could come up and draw a big long line like this. But those are arrows on the end, which means they never stop. So it's always the same line. So there's only one line that can be done like that, okay? And then the perpendicular postulate says the same, but with perpendicular. If there's a line and a point not on the line, so if I use that same point, then there's exactly one line that can be drawn through that given point that is perpendicular to that line. And perpendicular means right angle, okay? Again, the length of the line you use to represent it could be different, but it's still the same line. Yep.
So you mixed them up last time.
I just did it in different order. Yeah. Okay, transversals. So a transversal, again, another definition, is a line that intersects two or more coplanar lines in different points. Interior angles are angles that are in between the lines. So in between, not the transversal, but the lines that it intersects. And exterior angles are angles that are outside the lines that are being intersected. So if a transversal is a line that intersects two or more coplanar lines in different points, there's three lines in this diagram. Which of those lines is the transversal? M. M is the only one that's intersecting two lines. Do we see that? Yeah? So M is my transversal, which means to establish interior and exterior, I'm looking at J and K. The ones that are in between them are your interior. And the ones that are outside of them are your exterior. So my interior angles for this diagram are 3, 4, 5, and 6. My exterior angles for this diagram are 1, 2, 7, and 8. Questions so far? So now I can take and turn this in any direction you want. Sometimes your transversal is running left to right. Your interior is still always in between the two lines, and exterior is always outside, okay? They can rotate that diagram every way they want. So it's not always top and bottom and inside like that. It could be left and right, whatever the direction of the lines are going. All right, so it's special angles. Again, some more vocab, okay? And the first is called alternate interior angles. Alternate interior angles are two, so these come in pairs, two non-adjacent interior angles on opposite sides of the transversal. Alternate interior, so two non-adjacent interior angles on opposite sides of the transversal. And alternate exterior angles are also in pairs two exterior angles on opposite sides of the transversal. Here's my transversal again. This one's the same shape as last time, the same diagram, okay? So non-adjacent interior means it has to be interior, and non-adjacent, so not next to it, which means 3 goes with 6 and 4 goes with 5. So these, again, are written in pairs. My alternate interior would be angle 3 and angle 6, and angle 4 and angle 5. So opposite sides of the transversal, but not next to each other, and in between the two lines. Alternate exterior, same rules apply, except we're talking exterior. So these and these, they have to be on opposite sides, but they can't be next to each other, which means angle 1 goes with angle 8, and angle 2 goes with angle 7. Questions so far? Okay, 2 more types. The first is the same side interior. So think about the words that are there. Same side means it's going to be on the same side of the transversal. Interior, in between the two lines. 2 interior angles on the same side of the transversal. And then corresponding angles are 2 angles in corresponding positions relative to the 2 lines. So same side interior is, again, same side of the transversal in between the 2 lines. So one pair is angle 3 and angle 5. And the other pair is angle 4 and angle 6. They are not always like one on top of the other. Remember, this could rotate around, right? Now my transversal is running that way. They still have to be on the same side of the transversal, but in between, okay? So it's still the same pairing. 4 still goes with 6 and 3 still goes with 5. So keep in mind that this kind of shape is going to rotate all around. Questions on same side before I get into corresponding? Okay, so corresponding, the easiest way to look at it is if you make a little box around the 4 angles that are formed by the intersection of your transversal and the other line, then there are 4 corners. There's top left, bottom right, no matter how you turn that. And whichever one's in the same corner is what matches. So top left and top left matches, which means angle 1 and angle 5 are corresponding angles. Then top right and top right, so angle 2 and angle 6. Then bottom left and bottom left, angle 3 and angle 7. And last, bottom right, angle 4 and angle 8. So wherever they are in location, in relation to where those 2 lines cross, is how they match up.
There's same side.
So that was a good question. He just said, is there same side exterior? Nope, there's only these 4. So alternate interior, alternate exterior, same side interior, and corresponding. Those are the 4 special types of angles.
Can you explain corresponding angles?
Yep. So like if you look back, like let me rotate this because it could be rotated, right? So like let's say it's rotated like that. So if you can't see it, my advice is to literally draw that box. So if I draw a box around where these intersect, there's a box and there's a box, right? So if I'm looking for the match for 2, that 2 is in the top left corner of my box. I go to the next box and I look at the top left corner and it's 6. So 2 and 6 match. If I want to figure out match to 4, that's kind of like top right. So I'd go top right here and that's 8. 4 and 8 go together. Bottom left is 1 and 5. And bottom right is 3 and 7. And they're going to, like, these diagrams get complicated. They get turned. They get added lines, all that stuff. God bless you. If you can't see it straight off the bat, draw yourself that little box. Any other questions? That same side interior is also called consecutive
On the test, is it going to be
interior. I would take either one. Okay? It depends on which book you're reading at that moment, which one they go back and forth. Standardized tests go back and forth. Like, so it's good to know both. Same side interior, same thing as consecutive interior. Okay, so this example says classify as true or false. I want you to try these and then we'll go over them. All right, letter A says a transversal only intersects parallel lines. True or false?
false?
What makes it false?
Parallel line.
They can intersect parallel lines or
Perpendicular.
well, they can't intersect perpendicular because that wouldn't touch. Yeah, I guess they could if they were long enough. Yeah, you could do perpendicular because as long as it crosses this way, that's still a transversal, right? It's any two, right? Could be any two or more lines. How about B? Skew lines are not coplanar. True. By definition, they are not coplanar and they are also non-intersecting. C, if two lines are coplanar, then they are parallel. Okay, what else could they be? They could be parallel or not if they're coplanar. If they're coplanar, they're definitely coplanar, so they can't be skew. They could be these two, right, which would be parallel, but they could also be these two, yes? So they could also be perpendicular. They could be intersecting. They don't even have to have a right angle, right? Okay, so that's false. And D says if two lines are parallel, then exactly one plane contains them. True. Okay, if I've got a line here and a line here, only one plane, only one vertical plane can encase them. If you think back to like what we talked about in our postulates, if there are 2 points on this line and a point on this line, those are 3 non-coplanar points, and 3 non-coplanar points are contained in exactly one plane, one and only one, no more, no less. Sorry, no, yeah, 3 non-linear, thank you. So 3 non-linear points, or a line and a point not on the line, because that would be the same thing, lie in exactly one plane. All right, I'm going to add to this one. I don't know why it's not on there. But add D, which is alternate exterior. And then again, name the given angles. So you're giving me all of them, not just like one example, but all of them. Okay, so who can give me the alternate interior angles? Lewis.
Angle 6 and angle 3 and angle 2 and angle 7.
Good. How about same side interior? Gio.
Angle 6 and 7 and then angle 2 and 3.
Good. Corresponding. Go ahead.
The first is angle 1 and 3, and 2 and 4, and 5 and 7, and 6 and 8.
Good. Okay, alternate exterior. Kelly.
1 and 8 and 5 and 4.
Good. Questions on any of those? Okay, so I published your assignment. There is one more thing that you're going to see in tonight's homework that you need to know, which is the symbol for parallel. So if you see 2 lines that are obviously, they look like they're parallel, you can't assume they're parallel unless it states somewhere that they're parallel. So if it says like angle L, line L is parallel to line M, and so that L and M would say line L is parallel, that's what that means, to line M, or they have little arrows on them. So little red arrows, I think your book uses, okay? Those also state that they're parallel. So you're gonna see that in your diagrams. Just make sure you know the difference. Just because they look parallel doesn't mean you can assume it if that asks, okay? Or same for perpendicular. You need that little right angle, or you need it to say, like if it said, if I had this, oops, that's not what I wanted. Like looking perpendicular is not enough. If it was N, oops, not M. Then it would have to have a right angle box, or it would say L is perpendicular to N. The upside down T is that perpendicular, okay? Questions on anything we talked about today before you get to the homework, or the general question? Okay.